Okay, this is part 2 of a series of videos on graphs of motion. I'm going to continue on with distance time graphs. So let me draw a distance time graph. I'll have time down here. I'll have distance up here on the y-axis. And I'll have a graph that looks something like this. So what does this graph mean? Well, whenever you have a line like this at about 45 degrees, that indicates that the object is moving at uniform speed. Why is that the case? Well, because from before, speed is just distance divided by time. Okay, and that gives you a constant, that gives you a number. Okay, and speed is just the gradient of the graph, the slope. So the slope in this case gives us uniform speed. Whereas this line here, that indicates that the object is stationary. That's a fancy way of saying that it's not moving. So let's suppose the car's driving along, uniform speed, constant speed, and then it stops, let's say, for like, I don't know, 10 seconds here. Okay, the graph is flat because the speed, there's really nothing happening to the object. It's just sitting there, right? It's come to a stop. So the speed is 0. Okay, the slope, the line is horizontal, so therefore the speed is 0. Here, should make this a bit more obvious. Suppose the line here has a greater slope than this line here. That means that the object is moving fast. Okay, it's still uniform speed, but it's moving a bit faster. Okay, because the slope is greater. And here, this line going downwards, that's called a negative gradient, a negative slope. It's coming back down. What does that indicate? That indicates that the object is going back to its starting point. Okay, because it started off at, let's say, 0. It's coming all the way back down to its starting point. So that indicates that the speed is decreasing. Okay, because it's going fast here, then all of a sudden it's changing direction. It has to change, it's going fast here, then all of a sudden it's slowing back down, returning to its starting point. And that's how you interpret a distance time graph.